standard in which we are doing mathematics revision that is called as bridge course, which is a part of uh, a very important curriculum so that everything will be correlated. You should not get confused or you should try to find link whatever you have studied in your previous class to the current class, whatever you are studying. So following this protocols, we got three topics in which we have covered basics of all the topics. Yesterday we have done variations. I have told you that variation means change. In that we have seen a change of the type direct variation. Direct variation. So direct variation means if we are having two variables, x and y, if x increases, then y also increases. If you are going to say or x decreases, then y also decreases. This is called as direct variation. In this case, I have given you a particular example of notebook, price of a notebook, number of notebooks and price, or you can say cost of a notebook. After that, I have done some problems based on direct. So today we'll start with inverse variation. Inverse variation. Now, when it comes to inverse variation means one value, say one variable increases, then the variable, there is second variable associated to this variable decreases. Or if the first variable decreases, then the second variable increases. In the sense, the value of first variable increases and the value of second variable decreases. Value of first variable decreases, then the value of second variable increases. This is the relation between them. If we are saying x and y are in inverse variation, or inversely proportional. Say here we will be telling inverse variation. Or you can also say that x is inversely proportional to y. X is inversely proportional to y. So in this case, how we can write the notation for this is x alpha 1 upon y. Inverse means upon form. In the yesterday's lecture, when we were doing direct variation, so there we have written x alpha y. So here we are doing inverse variation. So we are writing x alpha 1 upon y. See the difference? From direct variation, what do we understand? From direct variation, we have understood that When we write x directly proportional to y, then we write x is equal to k into y, and then we write x by y is equal to k. Means in direct variation, x upon y is equal to k. So let's see what will happen in case of inverse variation. In inverse variation, we have x inversely proportional to 1 by y, means you are going to say x inversely proportional to y. Means the notation that I'm using is x alpha 1 upon y. Inversely means I'm writing y as 1 by y. So therefore, x is equal to k upon y, where k is constant of variation. Where k is constant of variation. Okay. So here we can write this as x into y, taking this y to left hand side. So x into y is equal to k. So our observation is that in inverse variation, product of the two quantities gives us constant. Product of two quantities gives us constant. In case of direct variation, the division of two quantities gives us constant. So this is the relation between constant and the variables. Hope you have understood this. So let's move to, actually this is called as equation form of a variable. The equation form. Okay. Now let's do some examples so that concept will get revised properly, and it will be more clear so that we can apply it in our class, that is grade 9, when we're going to start our proper syllabus. Now problems. I will be directly taking tabular form, in which we will be covering almost all the possibilities, and after that 1 to 2 word problems, and then we will wind up, and after that we'll start with polynomials. If A varies inversely as B, then we need to complete the following table. Yesterday we have not written K. Today we will be taking K also. K can be written as K, or you can write A into B, no problem. Say A, B, and we know that A into B is nothing but K. So this is our K. Say value of A, and we have one unknown. Here say we are having 6 and 20. Keeping K unknown. Here we are knowing the value of A, keeping two unknowns. Once you will get the value of K, it will remain constant throughout. Once you know this value is unknown, this value is unknown. So as A is inversely proportional to B, we can write A alpha 1 upon B. So therefore, A is equal to K upon B, where K is constant. Therefore, A into B is equal to K. Now we know the value of A and B when A is equal to 6 and B is equal to 20. Substitute the value and give it a name as equation 1. From equation 1, value of A as 6, value of B as 20 is equal to K. So write from equation 1. Therefore, K is equal to 6 to the 12 and 0. So we got value of K as 120. Now we can use this value throughout the table. Here also, so I can write here 120 as it is constant, so it will never change. I got the value as 120. So erase this. This table is required so that we can see the values and get the unknown values. Now, so therefore we have A into B is equal to 120. So this is my equation number 2. Now when value of B is not known to us, A is 12. So we need to get the value of B from, we know the value of A as 12, 12 into B is equal to 120. So that is B is equal to 120. Taking this 12 to right hand side, we take a form of division. So divided by 12. So we can write this as 12 into 10 upon 12. Or directly you can cancel, no issues. I'm just giving a simplification part. So we got our answer as 10. Okay. So I got the value of B as 10 here. Now what we need to do, we need to go for next part. When B is given as 4, A we don't know. So from equation 2, we can use the equation to in which K is already known, just substitute one value and get the value of another unknown variable. So as we know B, we can write it as A into 4, A into B is equal to 120. Therefore, A is equal to 120 divided by 4. 4 ones are 4 threes are. So when you can write this as 4 into 30. So I got value as 3030. So we have completed this table. Hope you have understood this problem. As the steps we can see was not that difficult. Only you should get the value of a constant of variation first. Once you got the value of constant of variation, which is constant throughout, you can use the value in each and every column as per requirement. Okay. So let's Move to next word problem. So the problem given is x inversely proportional to root y. X inversely proportional to root y. So find constant of variation when x is equal to 40, y is equal to 16. Find constant of variation when x is equal to 40 and y is equal to 16. Also find y if x is equal to 20. Very simple. Just its appearance becomes or looks tedious. Otherwise, it's very simple. Just use this condition, formulate the equation, use both the values of a variable which is given to get the value of constant of variation, that is k. Once you are through with k, you know x, substitute in the equation, and then get the value of y. Not that difficult. Let's do this. X inversely proportional to root y. So therefore, x is equal to k upon root y. Very simple, as normal, as usual that we do in case of constant or direct variation or inverse variation, where k is a constant. Where k is a constant of variation. Okay. After this, what we need to do? We need to write it as x into root y is equal to k. So this is say my equation 1. When x is equal to 40 and y is equal to 16, we need to find the value of k. So x into root y is equal to k from equation 1. The value of x is 40 into value of y is 16. So root of 16 is equal to k. That is k is equal to 40 into root 16 is 4. 16, 0. 160. 160 is the answer of k. Hope you have understood this. Now next part, what we need to work on, that is find the value of y if x is 20. I'll rub this. Now to find y if x is given to be 20. So x into root y is equal to 160. This is the equation that we have as we got the value of k. We are just substituting the value of k instead of k. So from here, what do we know? We know the value of x as 20 into root y is equal to 16. So as the variable y is unknown to us, just keep it on left hand side, take 20 to right hand side. We'll be getting therefore root y is equal to 160 upon 20, 0 cancel, ones are, eights are. But as we can see, x is 20, and we got value of and remaining part you can try. It's very simple. Now let's start with polynomials, a new topic, as we need to cover it as early as possible, the remaining topics, because we're going to start polynomials and linear equation in one variable. So today I will try to complete the polynomials part. Hope you have understood the concept of inverse variation and direct variation. So now we'll do division of polynomials. So before introducing to polynomials, first I will tell you what is polynomial. First question. Index of each term of algebraic expression in one variable, say take x square plus x minus 1. We have gone through this type of expression, no doubt. We can see that this 2 is the index. Whenever we write a raised to b, so b is the index and a is the base. So here we can see that if index of each term present is a whole number, if the index of the each term present is a whole number means start from 0, 1, 2 till infinity. Does not have any end. So you can see that here the power of x is 2, here the power of x is 1, and here no x is present. So you can write, if you want, in terms of x as 1 into x raised to 0. Anything raised to 0 is 1 by law of indices. So 1 into 1 is 1 again. So x square plus x minus 1. So if index is a whole number, then the given algebraic expression, you can call it as a polynomial. If instead we are having, say, x raised to 3 by 2 minus x plus 7, then my question, whether the given expression is a polynomial? No. The answer should be no. Why? Because 3 by 2 here, index of x is 3 by 2, which is not a whole number. So it is not a polynomial. One more example, say x raised to minus 1 plus x raised to 3 minus x square plus 1. So is this expression a polynomial? Again, your question is whether it is a polynomial or not. So answer should be no. Why? Because we can see that here the index of this variable x is not a whole number, and hence it is not a polynomial. So what we have understood from this, if index of each term of an algebraic expression in one variable is a whole number, then the expression is called a polynomial. This is the definition. So let's do some basics before starting with the actual form of that is called as division of polynomial. We will do some activity, which is very important, as we have done it in expansion of algebraic expression. Again, we are repeating here. 2a plus 3a. So as we can see that we can take a common. What will remain? 2 plus 3. So answer is 5a. Or directly 2a plus 3a. Both the variables are same, so we can add them. Yeah, if you will tell ki 2a plus 3a square. So here you can't add them, as the variable present along with the coefficient is different. Here it is a, here it is a square. So answer will be like this: a into 2 plus 3a. You can't merge them, as the variables are having a different index. Index of the first variable a is 1. Here the index of the variable is 2. Next, say if we are having 3p into p square. Now what we can see here, again we have to apply law of indices, keep 3 outside, and as base is same, we can write it as 1 plus 2. This is 3p raised to 3. If you want to recollect the information, we can write this as a raised to n into a raised to m. So answer is base is same, a raised to n plus m. This is the reason behind this. Since base was same, here the power was 1. So we have written it as p raised to n plus m, that is 1 plus 2. So answer is 3 into p raised to 3. Again, next. Say we are having 5 m square plus 3 m raised to 3. What do we need to do? Here you can't do anything. Just only thing what you can do is you can take m square common. As you can see, the least power is m square. It is present here as well. How? 5m square plus 3m square into m. We can see m square common, so you can write m square outside into 5 plus 3m. Okay. So instead, if we are having, say, multiplication in between, if we are having 5m square into 3m cube. Now, how to deal with this? So in this case, we can see that this base coefficient will get multiplied, no doubt. Whatever the variables present, they're having different signs. So 5 3s are 15. Multiply this. And after that, since base is same, you can write 2 plus 3, which is nothing but 15 m with index 5. Hope you have understood this. Let's take some other example. The next example is 2x plus 5y multiplied to 3 by x. When we open the bracket, so 2x into 3 by x, it gets distributed to both the terms present, plus 5y into 3 by x. So what do you need to do? Just strike x as it is present in numerator as well as denominator. And here we can see that nothing can be striked out. So 2 3s are 6 plus sign. So 5 3s are 15 y upon x. This is your answer. So our observation is that if variables are same, they're present in numerator and denominator, the power will get striked out if they're having the same index. But if the power is not same, so some will get striked and the remaining will survive, as we have done it in law of indices. If we are having x cube upon x square, so what rule we can apply? Is 2 3 minus 2, so answer is x. Or the other way is to write this as x square into x upon x square. X square cancel, what remains x. So both the methods are like they are going to give you the same answer. Way of writing is different. So now we will see how to find the degree of a polynomial, the greatest index of the variable in the polynomial. Now you have understood the meaning of polynomial. So how to find the index of the polynomial? If we are having 3x raised to 5 minus 9x square plus 1. So if I'm asking you what is the degree of polynomial? So just see the highest index, or you can say the greatest index of the variable in the given polynomial. You can see that it is 5. As index is 5, here index is 2, here index is 0. Why? Because one constant always have index 0, because we considered x raised to 0 along with it, or along with any constant. It's not having any variable. As the highest index present is 5, so degree of the given polynomial is 5. One more. If we're having say 7x square plus 4x minus 7, then also we can see that the highest index present in this is 2, so the degree is 2. Done. Okay. So this was based on degree. Now we will see how to divide two polynomials. Now, how to divide two polynomials? 5p cube, or you can say we're having 15p cube. divided by 3p. So we can see that we are having p cube, and here we are having p. So how to divide this? Once we know this, we can write this as we know that a divided b can be written as a by b. So here we are having 15p cube divided by 3p. Or else we know that how to write this as b dividing a. So we are going to use here this method, b dividing a. I will show you both the methods. And from both the methods, we are getting the same answer. First method, very simple. We can write this as 15p cube divided by 3p. We can write this as 3 5s are 15 into p cube can be written as p square into p, and just splitting the terms that I'm having to more simpler form. And here we are having 3 into p. Cancel 3 ones are 3 ones are, pp gets cancelled. What remains? 5p square. And when it comes to a division, you can go by this method. 3p, here we are having 15p cube. So our question is that we are having 3p here, and 3p has a divisor, and 15p 3 or 15p raised to 3 or 15p with an x3 as a dividend. So what number or what quotient should be taken with the divisor so that we will get 15p cube if we multiply 5p square, so that we can see 3 5s are 15. P into p square is p raised to 3. I'm getting this term. So 5p square should be multiplied with 3p, and after that we take opposite sign. So 15p cube minus 15p cube, answer is 0. So how we can express this? We can express this as dividend. Dividend is 15p cube. Divisor into quotient. Divisor is 3p. Quotient is 5p square plus remainder, and our remainder is 0. So this is our quotient. This is our dividend. This is remainder, and this is divisor. Okay, so we take one more example. Say if we are going to take both as negative. Hope you have understood both the methods. Whichever method you find simpler, you can apply to get your required answer. Say if we use minus 36x raised to 4 divided by minus 9x. So in this case, we can see that both the sign present is negative. So we can write it as minus 36 x raised to 4, and this is minus 9x. What number should we multiply to minus 9x so that we have to get minus 36 x raised to 4? If we multiply 4x cubed to minus 9x, so 9 fours are 36, minus sign, minus into plus is minus, x into x raised to 3 is x raised to 4. You can see that I got the requirement, minus 36 x raised to 4. So just take 4x to be here. This will be acting as a constant quotient. So we got minus 36 x raised to 4. We need to take opposite sign. So it will become plus. Minus of minus is plus. So terms with opposite sign gets cancelled. What remains 0. So this is our required answer. Hope you have understood this much. So in next lecture, we'll complete polynomials. Okay, everyone. Thank you.
Yes, sir. Thank you so much.
Thank you.